According to the National Electrical Code, a disconnect is indeed required in specific scenarios for transformers. The NEC Section 450.13 8.2 mandates a disconnecting means for transformers that are rated over 600 volts. Furthermore, NEC Section 450.13 B requires a disconnecting means for transformers rated over 75 kVA, kilovolt amperes. So, if a transformer exceeds either of these thresholds, a disconnect is not just for safety, it is a code requirement. Now, where should this disconnecting means be located? NEC Section 450.14 provides guidance on this aspect. Firstly, the disconnecting means must be located near the transformer. Secondly, it needs to be in sight from the high voltage side of the transformer. Thirdly, the disconnecting means must be capable of interrupting the full load current of the transformer. The reason for these requirements is rooted in safety. The disconnecting switch plays a crucial role in enabling safe maintenance and repairs in the transformer. By providing a means to isolate the transformer from the power source, it eliminates electrical hazards that could potentially arise during maintenance procedures. Consider a situation where a technician needs to perform work on a transformer. Without a readily accessible and code-compliant disconnecting means, the technician would be exposed to the risk of electrical shock or arc flash. This could lead to serious injury or even fatality. The disconnecting switch ensures that the technician can energize the transformer before commencing any work, thereby mitigating these risks. Now let us delve deeper into the technical aspects of these requirements. When determining the appropriate disconnecting means for a transformer, several factors must be taken into account. Firstly, the voltage rating of the transformer is paramount. As per NEC Section 450.13, 8.2 transformers rated over 600 volts necessitate a disconnecting means. Therefore, the disconnecting switch selected must have a voltage rating equal to or greater than the transformer's voltage rating. Secondly, the kVA rating of the transformer is equally important. NEC Section 450.13 B stipulates that transformers rated over 75 kVA require a disconnecting means. To determine the appropriate amperage rating for the disconnecting switch, you must calculate the full load current of the transformer. The full load current can be calculated using the following formula for a three-phase transformer: kVA times 1000 divided by volts times the square root of 3. For a single-phase transformer, the formula is kVA times 1000 divided by the volts. The disconnecting switch must have an amperage rating equal to or greater than the calculated full load current. Thirdly, the location of the disconnecting means is governed by NEC Section 450.14. The requirement that the disconnecting means be located near the transformer is intended to ensure easy accessibility in case of an emergency or for routine maintenance. The phrase "in sight from the high voltage side" means that the disconnecting switch must be visible from the high voltage terminals of the transformer. This allows personnel to visually verify that the transformer is indeed energized before commencing any work. Furthermore, the disconnecting means must be capable of interrupting the full load current of the transformer. This ensures that the switch can effectively break the circuit under normal operating conditions. It is important to note that the disconnecting means must be properly labeled to clearly indicate its purpose. The label should state that the switch is the disconnecting means for the transformer and should include the transformer's identification number or other relevant information. This labeling helps to prevent confusion and ensures that the correct switch is used when isolating the transformer. In addition to the NEC requirements, there may be local codes or regulations that govern the installation and maintenance of transformers and disconnecting means. It is essential to consult with the local authorities having jurisdiction to ensure compliance with all applicable codes and regulations. The selection and installation of the disconnecting means should be performed by qualified and licensed electricians who are familiar with the NEC and local codes. These professionals have the expertise and knowledge to ensure that the installation is safe and code compliant. Regular inspection and maintenance of the disconnecting means are crucial to ensure its proper functioning. The switch should be inspected for any signs of damage, corrosion, or wear. The contacts should be cleaned and lubricated as needed. Any defective or worn parts should be replaced promptly. Moreover, it is essential to establish and implement lockout/tagout procedures to prevent accidental energization of the transformer during maintenance or repairs. Lockout/tagout procedures involve disconnecting the power source, locking the disconnecting means in the open position, and attaching a tag to the switch indicating that it is not to be energized. These procedures help to ensure the safety of personnel working on the transformer. In summary, the NEC mandates a disconnecting means for transformers rated over 600 volts or 75 kVA. The disconnecting means must be located near the transformer, in sight from the high voltage side, and capable of interrupting the full load current of the transformer. The purpose of these requirements is to ensure the safety of personnel during maintenance and repairs. It is important to consult with qualified electricians and local authorities to ensure compliance with all applicable codes and regulations. Proper installation, inspection, and maintenance of the disconnecting means are essential for its reliable operation and the safety of personnel. Consider the scenario of installing a new transformer in a commercial building. The transformer is rated at 480 volts and 100 kVA. According to NEC section 450.13, a disconnecting means is required because the transformer is rated over 75 kVA. The electrician selects a disconnecting switch with a voltage rating of 600 volts and an amperage rating sufficient to handle the full load current of the transformer. The disconnecting switch is installed near the transformer and is visible from the high voltage terminals. The switch is properly labeled to indicate that it is the disconnecting means for the transformer. During a routine maintenance inspection, the electrician notices that the contacts of the disconnecting switch are corroded. The electrician cleans the contacts and applies a lubricant to ensure proper operation. The electrician also verifies that the lockout/tagout procedures are in place and that all personnel are properly trained. By adhering to these requirements and procedures, the electrician ensures the safe and reliable operation of the transformer. Understanding the NEC requirements for transformer disconnects is essential for electrical professionals and anyone involved in the installation, maintenance, or repair of transformers. By following these guidelines, you can help to ensure the safety of personnel and the reliable operation of electrical systems. Consider a situation where a transformer is located in a remote area of a facility. The distance between the transformer and the main electrical panel is significant. In this case, the NEC requirements for a disconnecting means become even more critical. The disconnecting switch provides a local means of isolating the transformer from the power source, eliminating the need to travel back to the main electrical panel to de-energize the equipment. This saves time and reduces the risk of accident. In addition to the safety benefits, a disconnecting means can also improve the efficiency of maintenance operations. By providing a readily accessible and code-compliant disconnecting switch, technicians can quickly and easily de-energize the transformer, allowing them to perform maintenance tasks without delay. This can help to minimize downtime and improve the overall productivity of the facility. Furthermore, a properly installed and maintained disconnecting means can help to extend the life of the transformer. By providing a means to isolate the transformer from the power source, the disconnecting switch can prevent damage caused by voltage surges or other electrical disturbances. This can help to prolong the life of the transformer and reduce the need for costly repairs or replacements. It is important to note that the NEC requirements for transformer disconnects are not static. The code is regularly updated and revised to reflect changes in technology and industry best practices. Therefore, it is essential to stay up to date on the latest code requirements and to consult with qualified electrical professionals to ensure compliance. One common misconception about transformer disconnects is that they are only required for large, high-voltage transformers. However, as NEC section 450.13 makes clear, a disconnecting means is also required for smaller transformers rated over 75 kVA. This means that even relatively small transformers used in commercial or industrial applications may require a disconnecting switch. Another important consideration is the type of disconnecting means that is used. There are several different types of disconnecting switches available, each with its own advantages and disadvantages. The most common types include fused disconnect switches, non-fused disconnect switches, and circuit breakers. The choice of disconnecting means will depend on the specific application and the requirements of the NEC and local codes. Fused disconnect switches provide overcurrent protection in addition to disconnecting capabilities. These switches are typically used in applications where overcurrent protection is required, such as for transformers that supply sensitive electronic equipment. Non-fused disconnect switches provide only disconnecting capabilities and do not offer overcurrent protection. These switches are typically used in applications where overcurrent protection is provided by other means, such as a circuit breaker in the main electrical panel. Circuit breakers can also be used as disconnecting means for transformers. Circuit breakers provide both disconnecting capabilities and overcurrent protection. These devices are typically used in applications where space is limited or where a high level of protection is required. When selecting a disconnecting means for a transformer, it is important to consider the interrupting rating of the switch or circuit breaker. The interrupting rating is the maximum amount of current that the device can safely interrupt. The interrupting rating must be equal to or greater than the available fault current to the location of the transformer. The available fault current is the amount of current that would flow in the event of a short circuit. The available fault current can be calculated using various methods, such as a fault current study. Failure to select a disconnecting means with an adequate interrupting rating can result in a catastrophic failure in the event of a short circuit. This can lead to equipment damage, fire, and personal injury. In addition to the interrupting rating, it is also important to consider the voltage rating of the disconnecting means. The voltage rating must be equal to or greater than the voltage of the transformer. Using a disconnecting means with an inadequate voltage rating can result in insulation breakdown and electrical shock hazards. Proper grounding of the transformer and the disconnecting means is also essential for safety. The grounding system must comply with the requirements of the NEC and local codes. The grounding system provides a path for fault current to flow back to the source, allowing the overcurrent protection devices to operate and clear the fault. Improper grounding can result in electrical shock hazards and equipment damage. Regular testing of the grounding system is recommended to ensure its integrity. The testing should be performed by qualified electrical professionals using calibrated test equipment. The results of the testing should be documented and kept on file. In addition to the NEC requirements for transformer disconnects, there may be other applicable standards and guidelines. For example, the National Fire Protection Association, NFPA, publishes several standards related to electrical safety, including NFPA 70E, Standard for Electrical Safety in the Workplace. NFPA 70E provides guidance on safe work practices for electrical workers, including procedures for de-energizing and isolating electrical equipment. Compliance with NFPA 70E can help to reduce the risk of electrical accidents and injury. It is also important to consider the environmental conditions in which the transformer and disconnecting means are installed. For example, if the equipment is located in a damp or corrosive environment, it may be necessary to use special enclosures and materials to protect against corrosion. The enclosures should be rated for the specific environmental conditions. The materials used for the enclosures and other components should be resistant to corrosion and other forms of degradation. Regular inspection and maintenance of the enclosures are essential to ensure their integrity. In some cases, it may be necessary to provide additional protection against lightning strikes. Lightning strikes can cause voltage surges that can damage or destroy transformers and other electrical equipment. Lightning protection systems can help to mitigate the risk of lightning damage. These systems typically consist of lightning rods, grounding conductors, and surge protective devices. The lightning protection system should be designed and installed by qualified professionals in accordance with applicable standards and codes. In summary, the NEC requires a disconnecting means for transformers rated over 600 volts or 75 kVA. The disconnecting means must be located near the transformer, in sight from the high voltage side, and capable of interrupting the full load current of the transformer. The purpose of these requirements is to ensure the safety of personnel during maintenance and repairs. It is important to consult with qualified electricians and local authorities to ensure compliance with all applicable codes and regulations. Proper installation, inspection, and maintenance of the disconnecting means are essential for its reliable operation and the safety of personnel. When selecting a disconnecting means, it is important to consider the voltage rating, amperage rating, interrupting rating, and environmental conditions. Regular testing of the grounding system is also recommended. Compliance with applicable standards and guidelines such as NFPA 70E can help to reduce the risk of electrical accidents and injuries. By following these guidelines, you can help to ensure the safe and reliable operation of transformers and other electrical equipment. It is important to remember that electrical work can be dangerous. Always follow safe work practices and consult with qualified professionals before performing any electrical work. Do not attempt to perform electrical work if you are not qualified or if you are not comfortable with the task. Electricity can kill.